Let's carefully analyze. Huh? We'll try. So what is our question? Just after spring 1 is cut, find the, okay, I'll put a boundary. Find the acceleration of blocks for the following situation. Here, find the acceleration of blocks.
Sir, now string 1 is not cut, sir. Only spring 1 is cut, or both are cut?
Only when agreed. Okay.
Yes, sir. Okay, sir.
Spring 1, sorry. Make observation. No, put effort. Nothing. Don't get scared anything. Already we have some equilibrium. Okay, there's no problem. Okay, well, anything. What will happen to spring when you cut spring? What will happen? This is one primary question we have to ask ourselves. The spring force will vanish. So what is the idea now? What is the basic idea? I'll introduce that idea. When spring is cut, the spring force in it, this is ideal. Practically there are so many other complications are there. We are at a very beginning stage. Let's this is what it was advised for us. Vanishes means spring force will become 0. Quite easy. Then any string connected to spring, the tension in that also will become 0. So string 2 and spring 1, these are very important for us. So let me bring the diagram. I think with this problem you can manage, let the spring or string cut, you can manage. I think I had to show spring cut, no? Yeah. This for your let's show like this. No spring 1 is cut. Spring force 1, that 6G will vanish. Now look at this. This string 2 is connected to spring, no? Here. This one.
Yes, sir.
So anything will happen to this tension, it will vanish because it's directly connected to the spring. So you do one thing, you may not agree this, just take the spring balance. For the spring balance, you tie a rope, and for the spring balance, you hang some mass. You cut the spring balance, the string will become loose. String 2 will not get cut. The tension in that will be 0. So here we'll give a reason.
Sir, tension in the string 2 vanishes in the sense what, sir?
Wait, no, let me explain. Please wait, have
Okay,
patience. The string 2 is directly connected to spring 1. When spring 1 is cut, the spring force in 1 vanishes, and at that instant the tension in string 2 all will become 0. Though tension 0, it will remain straight. Sir, is it a taut? No, just straight. I'll remove this 6G. Okay, no tension. We'll write it here. Okay, fine. Okay, now block B, what will happen to block B? Here we have to be careful. What about tension here? 2G, we don't know. Call it some T1. This is the beauty of this problem. Now what will happen? Acceleration of block C should be downward, no? Why downward, anybody? Because 5G and its weight both are acting downward, so it must be like this. Then what about here tension? How much we don't know. So call this as T3.
Sir,
Ah,
sir, string 2 is extensible string, sir.
strings are inextensible. Hollow laws of motion. That's what no string is inextensible, massless. Huh? Why new things you people are bringing?
No, sir, doubt I got, sir, because that acceleration, it will be downwards, no, sir.
String is inextensible, my dear. Take it for granted. Write in your notebook bold words. Huh?
Okay, sir.
Okay, now don't change the physical conditions. Huh? This is wrong. Okay, now we are here. So what we have to calculate is like a the spring is cut. Okay, there's one. What about acceleration of A and B? Will calculate first. So shall we work out this particular problem here? This will be 2G minus T1. They must have same acceleration. Any reason? They're connected by a common string. So 2G minus T1 equal to mass of the block A, 2A. Then 4G plus T1 equal to 4A. Let me add up this. 6G equal to 6A. So A equal to G. If A equal to G, substitute here. Then how much tension? T1 then. Like this we have to conclude. T1 I'm indicating tension the string 1 will be 0. But it will be, sir, like you are showing state. Let it be. Now come for here acceleration of block C. What shall I write? This will be mass of the block is how much? Mass of the block C is 1 kg. MC into AC equal to
5G, 6G.
mcg plus 5g. This is 1 AC. AC we have 6g. In what direction? Downward. Okay. Okay, somehow we got it. Let's come for this one. What will happen here? Spring force suddenly will not change. When you cut this spring, this sudden change in spring force in spring 2 will not change. So that's we'll write it here.
AD and A will be 0, sir, then.
Yeah, that's what we have to prove. I'll prove that one. Huh?
Sir, then how T3 will come, sir, if spring force doesn't change?
Wait ma. Let me explain. Huh? Spring force in spring 3 will not change. Spring force in spring 2 will not change. That already we know it. Okay, now what to do now here? So something T3 is there. Sir, you brought some other tension. Let's calculate. Now I'll assume that acceleration of this A dash. I don't know. Let's calculate. There'll be a test or in motion. Anybody? There'll be a test and tension the string will not change. I will write the equation now. 3g minus T3 equal to 3a dash 2g plus 23 equal to 2a dash. You add up this 5g 5a dash. A dash equal to g. If a dash equal to g, substitute here t3 is a dash equal to g. So how much t3 will come? One more. So okay, this one 2g plus t3 minus 5g here equal to 2a dash. Adding up this one 5g minus 5g. A dash is 0. If a dash is 0, substitute t3 will become 3g. Tension in the string will change, in the string 3 it will not change. Let's assume everything and conclude rather than it will happen like this. Getting the method? Look at your teacher, what is doing. Sir, tension in the string, why it will remain constant. What I should explain is there's a better way, no? If I, instead of writing t3, if I say it will remain same, I think it's a blind guess, no? We have given a proper proof. So what is the acceleration now? AD equal to AE 0. So what is the thing? Any string connected to spring. If you cut the spring, any string connected to that spring, there the tension will vanish. This idea.
Sir, if a spring is next to another spring, sir, and that spring is cut, will there be any error, sir?
Work out. It's not a story, no. It's not like some
Yes.
Taj Mahal,
Yes,
where
sir.
if you ask me, I'll carry. We have to work out. Everything I should work out like this.
Sir, if a string is cut, it takes much time for spring force to change. But if a
Yeah. If a
spring
spring
is
is
cut,
cut,
it doesn't.
then tension the string will change.
Okay.
The string is directly, this string 2 is directly connected to spring, no? So any change here will be reflected here.
But if in middle any mass is there, then it
Then
will change.
if any mass is here, then this tension again you have to work out in this way.
Okay, sir.
That's why I suggest you take this problem, cut all one by one and work out.